Quadratic equations, complex numbers. We already know the quadratic function ax squared bx plus c equals 0, or a is not equal to 0. We've been dealing with the quadratic function, or the quadratic formula. The new part is called the discriminant, b squared minus 4ac. What's on the inside of the radical? The discriminant tells us how many solutions, roots, x-intercepts an equation has. Now, the discriminant tells us how many roots we have. If the discriminant is greater than 0, then there are two distinct real solutions. And all those problems we did in the last section, inside the square root, if it was a positive number, we knew we had the plus or minus the square root, correct? If it's equal to 0, there's only one real solution. Well, I'll just use an example. I have 3 plus or minus the square root of 51 over 2. I know it's 3 plus and 3 minus, right? If it's 0 in here, it's just 3 over 2, because it's plus the square root of 0, plus or minus square root of 0. It only has one solution. And what's the last one?
Less than 0.
If this was negative, what does that tell me? There's no solution. If there's one, it's called a double root. It only hits in one spot.
That's the only correct answer. What's the error?
Yeah, if you try taking the square root of a negative number right now, it's going to give you an error.
Right now? Oh, God. Oh! What are we doing now?
Do you understand what the discriminant is? It just tells me how many answers I'm going to get. If you take what's on the inside of the square root, and it's a positive number, you got 2 answers. If it's 0, you know you only have 1 answer. If it's negative, you have no solution. That's what you're doing. It's telling you how many zeros you're going to have. You know by looking at that, am I going to have 2 answers, 1 answer, or no answer?
Sure.
All right, if it has one solution, how many places does it cross the xy axis? 1 spot. So what it's saying is, let's give this crosses the x-axis on how many spots? 2. I have a root there and a root there. How many spots does it cross the x-axis? 1. It is a double root. That would be like I have x minus 3 squared. It only hits at 3 twice.
So we've only been doing the first one and then
We've been doing this, but you didn't know it. And if it's something like this, does it cross the x-axis? No, that's why there's no solution. So we have 2x squared plus 4x plus 1 equals 0. Find out how many solutions I have. All right, to find the discriminant, all you look at is b squared minus 4ac. So it's 4 squared minus 4 times 2 times 1, which is 16 minus 8, which is 8. How many answers will I have? 2. That's it. So I know I could use the quadratic formula and finish it off and actually find out what they are. So I have negative 4 plus or minus the square root of 8 all over 2 times 2 is 4. To simplify, take this 8. 8 means 2 and 4, 2 and 2. Do I have any pairs? I have one pair of 2, so it's actually negative 4 plus or minus 2 square root of 2 over 4. To simplify, negative 4 over 4 is negative 1 plus or minus 1/2 square root of 2. But the better way to write it is the square root of 2 over 2. Instead of writing 1/2. So it would be negative 1 plus square root of 2 over 2, negative 1 minus square root of 2 over 2. Those are my two answers.
Where did you get over 2 from?
Find just the discriminant for this one. The discriminant for this one. All I'm going to do is take negative 6 squared minus 4 times by a, which is 3, times by c, which is 3. So it's 36 minus 36, which equals 0. How many solutions will I have? One solution. Awesome. Find the discriminant for this one. All right, the discriminant for this one is I'm going to have 4 squared minus 4 times by my a, which is 2, times by 3. So I have 16 minus 24, which tells me negative 8, which means I have no solutions. So by doing this ahead of time, it could save you work than trying to find out if there's an answer. Right now it told me no solution. Don't even bother going through the quadratic formula. Any questions?
So can we do this before we start answer?
Yes. In the second part of the lesson, we're going to start to talk about imaginary numbers.